Hi, everybody. Welcome to Screencast 2 of Renewable Energy. This is solar energy, one of my favorite things. And your lab this week, if you were the red class, you already had it. But for blue, pink, and green, you guys are going to do a lab. It's going to be to watch a PowerPoint and then to answer questions based on my father's old solar panels, which you guys are going to learn about today. Okay. So, I wonder if I can move this. Oh, look, I'm gonna put that there. So we're gonna move on to, well, there we go. Solar energy. Okay, solar energy directly comes from the sun, and you have two different types. There's active and there's passive. So when we're talking about passive, this means like when you guys go outside and you feel the sun hitting you and you warm up, you're not creating energy, you're not photosynthesizing or doing anything with it. It's just literally warming yourself up. Okay. So passive solar energy is when we use this solar energy to heat our house. Okay. So when you design your house or a building a certain way to take advantage of passive solar heating, it's because you can heat and you can shade from the sun in the summer and you can be exposed to the sun in the winter. Okay. So the building itself or some element of it takes advantage of that natural energy characteristic. Okay. So it collects heat during the day that's released slowly at day during the day or at night. You have very efficient insulation, and then sometimes you have a backup heating system. Most times you do. All right. So take a look at this image here. You have you guys know about the tilt of the Earth according to the season. So if this is weird, if this is the sun here and this is the Earth, okay, in the northern hemisphere, when we're tilting towards the Earth, it is summer. When we're tilting away, it's winter. Okay, right now we just started spring. Oh, happy spring! So we're starting to tilt towards the sun. Okay, so the angle of sun instead of it normally when sun rises in the summer, the zenith of the sun comes like right up over us, whereas in the summer, it kind of goes like this. You get more southern exposure. So what happens is you have this. There we go. What you have is, I guess we're going to highlight this. Um, you have this overhang that in the summer it blocks the sun from coming in, but in the winter it allows the sun to come in because of the angle of the sun. You have super windows. The best insulator is air. So it's a triple pane window. So one, two, three. So you have two insulations there. So if it's warm inside, it's going to stay warm inside. Or if it's cold inside, it's going to stay cold inside. A lot of times you have a stone floor and stone walls for heat storage. Like our building is made up of all cinder block. So when it's cold, it takes a long time for it to heat up. But then what happens is those cinder blocks tend to stay warmer and then it'll actually radiate heat, which is why in the building, once it gets hot, it gets really, really hot. But when it's cold, it takes a long time for it to heat up. Okay. A lot of times heavy insulation, light colored roofs to reduce overheating, heating, and then you have a vent that allows hot air to escape in the summer. Most of you probably have an attic fan. Mine was going the other day because when it starts to get hot, it sucks the heat out of the house. Right. So when you have active and passive combined. Your active is when you're actually then taking that solar energy and you're heating up water, or you're taking that solar energy and you're making electricity with it. Okay. So if you take advantage of active and passive together, then you can actually save a lot of energy. Okay. So in Greece, we have a water tank up on our roof, and it has one solar panel, and that solar panel heats the water by running it's the tubes kind of through it. So it's not generating electricity. That what looks like a solar cell is actually warming the water. It's concentrating the heat, and you'll see that. Okay. So, active solar heating systems. Okay. These are your solar panels. These capture energy from the sun. They pump heat through an absorbing fluid. It uses special collectors mounted on the roof. Okay. And this can be stored and released as needed. Okay. So, this is that water or that liquid is heated up and it gets pumped through the house. Okay. This isn't solar, these aren't photovoltaic cells. Okay. These aren't creating electricity. It's just the water or the fluid in it is getting superheated and then it's going around the house. Okay. So here are some advantages and some disadvantages. Go ahead and just take a look at those. They're on your notes as well. There we go. Now, solar power. Okay. Oops. There we go. So solar powered stations are either central receiver systems, distributed receiver systems, or parabolic dishes. In the past, I've had you guys memorize what is what. I'm not going to have you memorize these. Okay. So I want you guys to know the general idea of them because they're pretty cool. So in a central receiver system, what happens is they use mirrors. So none of these are photovoltaic cells. These are not solar panels like you guys are used to. But what happens is there are a whole bunch of mirrors, okay? And think of Austin Powers, which you guys are probably too young for. And what happens is all of the sunlight comes in and it gets reflected onto a single point, kind of like taking a magnifying glass and burning ants. Okay. So what happens is the focused light goes into this one spot. So it's super, super heated. It heats a water or molten salts, which are pumped into the tower. And then that hot water and that creates steam. That steam is used to turn the turbine. The turbine turns the generator. So what we see here is instead of using coal, oil, or natural gas or nuclear to create steam, what you're using concentrated solar energy, which is pretty cool. Okay, they operate at insane temperatures. Okay, distributed receiver systems are very similar in that it takes this parabolic dish, as you can see right here, and it concentrates the sun onto that pipe, which has usually an oil in it with a high specific heat capacity. And those pipes then go in through the water. They make the water boil to create the steam to turn the turbine to turn the generator. Okay. Then parabolic dishes. These are cool because it's the same thing. They're taking all of this solar energy and they're concentrating it. And they're concentrating it, though, into a specific engine um, that uses focused light in an expansion chamber and a fly cylinder. And what that does is that turns the turbine. So it's almost like wind energy, which is caused by the sun, because the wind energy is the changes in the heating of the earth creates the wind. Here, it's the temperature changes in this little Stirling engine that actually creates this flywheel to spin. Okay, you don't need to know the specifics of these three. What you do need to you need to know is how photovoltaic cells work, and we're going to get to those in a minute. Solar ovens can be really, really helpful, especially in developed countries. Um, in France, that one solar oven you can see here up top, this produces crazy temperatures of 3,500 degrees Celsius. I don't even know what that is in Fahrenheit. It's used for high temperature research. Whereas on the lower right hand side, you see this woman next to literally a grass hut is using a parabolic cooker, a solar cooker, to probably boil water. And these solar ovens are amazing in areas, especially where they don't have fuel wood or they're chopping down rainforests to get to their fuel wood. Okay. I'm going to give you guys three links. Two of them are here on solar ovens because they're just cool. And depending on what it is that happens, I used to do a solar oven project. I'd love for you guys to do that at home or some sort of aspect of that. So I want you guys to know how these solar ovens work. We'll see for the fourth marking period what we kind of want to do after the AP exam. Okay. Solar panels. You need to know how solar panels work. These are actually my pictures. This is a picture from on top of a closed um, garbage dump somewhere in Connecticut. Okay, and this is on the roof of I think it's like Coco Chanel Cosmetics in Edison or something like that. But I need you guys to watch this video. Okay, I'm gonna link it in the in with Google Classroom. Okay. And this is some sort of solar panel field that was being built somewhere up in upstate New York. So what happens is they have to build all the scaffolding first, and a lot of times with these solar panels on scaffolding like this, what they end up doing is they'll track with the sun. So as the sun rises and the sun sets, they'll actually optimize the angle so that they can have the most efficiency for that solar panel. We're talking about solar panels. They're not super efficient. The most efficient ones are 23 to 25% efficient, but most of them come in around 15% efficient, which isn't great, but those numbers are increasing all the time. Okay, so these were my father's solar panels, which you guys are going to do the lab on. As you can see here, this is all boarded up. That was for Sandy. And this is what that garage looked like after Sandy. And this is what we were finding. Okay, you see this bottom picture? That's the top layer of the glass layer with the silica in it has actually separated from the bottom half of the panel and just rolled up. It was insane. So this list was updated in January 2019, and I do have the newest ones as well. But if you look 1 through 5, China, India, India, okay, the largest capacity for solar fields in the world, 1,547 megawatts, which is a lot, and it's absolutely amazing. Mexico, India, 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 India. Okay, and then when we get to number 11, move this, that's where we get the United States. Okay, largest one is in California. Okay, then we go to Nevada and Desert Sunlight. I think that's in Arizona. And then Topaz Solar Farm. I don't know where that one is. Okay, and then China, India, China, China, US. These are current numbers. Look at these numbers. So this is 1547 was the top one, but look at India, man. Two systems over 2,000 megawatts each, which is absolutely amazing. You have Egypt coming in, United Arab Emirates, India, China, and on this list, the US is 15, 16, and 17, okay, which is some really great news for around the world. Now, there are a lot of advantages, okay? No carbon dioxide or low carbon dioxide emissions, but that's not for the actual creation of the solar panels, okay? Like with anything, we're not running on total renewables. If we were running on totally renewable, then actually making the solar panels would be a more environmentally friendly, less CO2 option. There's a relatively high net energy gain, okay? We're at 23% now with a lot of the solar panels. However, you need a huge land area for it. The ground is shaded or disturbed by larger solar panels, and you can have some habitat destruction underneath that. You need a backup system because the sun sets at night and then they stop producing that energy, and we don't have those storage systems yet. And you need a lot of sun. We have good solar capacity in New Jersey, but the thing is that I mean, this past month even, we've had a lot of gray days, and you still are producing electricity on those gray days, but it's not as much as it could be. Okay. And they're pretty low efficiency compared to fossil fuels. Okay. So I'm going to link those other videos, and there's going to be a couple questions for you guys to answer that go along with this. And I'm going to do some Google Meets. I can do Google Meets with classes for you guys, whatever questions you have. I'll send that information out on Classroom and via Remind. Okay.